Hello, and welcome back to the Cosmic Companion. This week we look at how astronomers may find life on distant exoplanets, and we examine the deaths of stars and the formation of black holes. One black hole may not be as large as was originally measured, while another may not be there at all. The TESS spacecraft finds a planet orbiting a pair of stars, like Tatooine from Star Wars, and a massive exoplanet is seen spiraling toward its sun. Water is seen leaving Mars at a far greater rate than expected, and new calculations shed new light on the deaths of stars. Astronomers know of more than 4,000 planets orbiting stars other than our own sun. However, examining the atmospheres of these worlds is at the very limits of what astronomers are currently capable of carrying out. However, the James Webb Space Telescope, due for launch in March 2021, will have the ability to determine the chemical composition of these alien atmospheres. Signs of large quantities of oxygen in the air of alien worlds could potentially be a sign of life. New research from the University of California, Riverside suggests that the Webb telescope could find oxygen surrounding distant exoplanets by studying patterns in how these molecules block light. Using this method, astronomers may be able to easily detect oxygen in the atmospheres of distant worlds. Stay tuned next week for an interview with an astronomer on this project. A recent discovery of 13 massive black holes at the centers of dwarf galaxies could aid astronomers seeking to understand how black holes formed in the early universe. Each of these galaxies is less than 1% as large as the Milky Way, and the black holes they contain hold 400,000 times as much mass as our own sun. By studying these black holes, researchers at Montana State University found that these objects could form even as their host galaxies underwent periods of vigorous star formation. This unexpected result shows that the earliest galaxies were also capable of forming similar black holes when the universe was still young. In a case of a missing black hole, astronomers saw two supermassive black holes within a pair of merging galaxies called NGC 6240. Calculations suggest this body should also be home to a third supermassive black hole, but no such body is yet visible to astronomers. If the expected third member is present in the system, the galaxies would spin together like a disk. Instead, the system is ejecting gas at velocities exceeding 500 kilometers a second. Astronomers are hoping to understand how this movement takes place and why a third supermassive black hole is not found in that system. In other black hole news, one of these objects seen near the center of the star system LB1 may not be as large as originally calculated, new studies suggest. Late in 2019, astronomers reported that the supermassive black hole contained in the system consisted of a mass of around 70 times greater than that of our own sun. Such a finding was inconsistent with models of the formation of black holes. Now, as astronomers study objects, conclusions are based, in part, on comparing one measurement to other calculations, such as determining the distance of a star from Earth based on its brightness. New interpretations of data from this black hole suggest it is significantly smaller than initially believed. Using the new TESS spacecraft, launched in 2018, astronomers have found a planet orbiting a pair of stars in the TOI 1338 star system. Most stars are accompanied by one or more stellar partners, so binary star systems are fairly common. However, it is challenging to find planets in these families of stars due to the complex gravitational attraction in such systems. The now defunct Kepler spacecraft found 12 of these worlds, and TESS is expected to find 100 more during the course of its mission. Roughly 600 light years from Earth sits WASP 12b, a massive world orbiting close to its star where it bathes in extreme heat and radiation. This hot Jupiter completes each journey around its sun in just 26 hours. The massive gravitational pull exerted on this world by its local star results in the planet slowly spiraling inward on a solar death plunge. As the planet spirals in toward its star, it orbits more quickly. As gravity tears the world apart, it will be orbiting its star once every 14 to 18 and a half hours. By comparison, the planet Mercury takes 88 hours to circle the sun once. Astronomers are expecting WASP 12b to be destroyed by its parent star in roughly 3 million years. Billions of years ago, Mars was a world with oceans, rivers, and ponds. The loss of its magnetic field left the world a barren desert. Still, some water remains on Mars, found at each pole and underground. However, a new finding shows that as summer comes to each hemisphere of the red planet, water driven into the atmosphere can escape to space much more quickly than previously believed. Several spacecraft are due for launch to Mars during the upcoming year. Stars, like people, are born, they live out their lives, and they die. Astrophysicists have long described the final stages of life cycles of stars as experiencing one or more periods of collapse. But a new study shows they may, instead, go through massive thermonuclear explosions at their cores. Our understanding of the death throes of small and massive stars is significantly more detailed than what we know of stars having between 7 and 11 times as much mass as our Sun. Nuclear accelerators here on Earth could be used to study the properties of these stars in an effort to learn more about the behavior of these bodies at the end of their lives. If you enjoyed this show, please download and share the episode on YouTube or any major podcast provider. For more details on space and astronomy news, please visit thecosmiccompanion.com.